Okay, so Roman numeral 5 we're doing together. The first part is just a review of rearranging algebraic equations. So on this first part, it wants you to solve the equations for the required variable, the unknown, by placing it on the left-hand side of the equal sign. So what we're going to do is just rearrange those and get one variable isolated, and we're going to put that one on the left. So for example, this first one, it wants me to solve for t, and the t is right here on the bottom. Okay. Do you know how to get that moved to the other side? Yeah, multiply by t. Did you have another question too?
No.
Okay. So what we're going to do is multiply both sides by t. Okay. Those are supposed to be parentheses, sorry. I'm out of practice writing. So the t's are going to cross on this side, so that's going to give us a t times a v over here. And then since they canceled on the right, we're left with just a d. Okay. And then since we're solving for time, which is the t in this case, we want to take this v and move it over to the other side. So now what do I need to do? Good, divide it. Okay. So we're going to take both sides and divide by the v. Okay. What that does is it's going to cancel out on the left, and now we're left with just t is equal to d over v. It will actually work for the same for both of them. Okay.
I didn't print the notes. I don't have a working printer.
That's okay. Just write down what you can for today. So on this one, we're solving for x. There are a few different things you can do to rearrange this one. Normally, though, when I see a fraction on both sides, I like to cross multiply and get everything all in one line. So what we're going to do is I'm going to take ay times s, and I'm going to set that equal to, and then I'm going to cross multiply the other way, cb times x. And since we're looking for x, I want to divide by everything that's not x so I can get it by itself. So just like we did before when we divided by v on both sides, we're going to divide by everything that's not x. And you can do that in one step. You don't have to divide by c and then also divide by b. You can do it all together. So it's going to cancel out. And we're left with ay times s divided by cb, and that's equal to x. But it wanted the unknown variable placed on the left-hand side. So once you get two things equal to each other, you can just flip them. So I could rewrite this and say x equals, and then everything that was on the left, I'll just switch it over to the right-hand side, and that would give us the same thing. Okay. Do you have questions on this one? So when we start out the school year in our chapters for physics, we're going to start out with basic equations, kind of like these, a little bit simple, multiplying and dividing, maybe a little subtraction. And then as we progress throughout the year, we'll get into things that are squared or square rooted, and we'll practice with those when we get to them. Okay, on this one, we want to solve for m, which is right here. Okay. Notice on this one how the term with m in it is separate than the plus b on the other side. I actually need to take this plus b and move it over. Do you know how to do that? Okay, subtract. So we're going to subtract b on both sides, and that's going to leave us with y minus b, and that's equal to mx. And then it looks like the ones we did before, where all you need to do is divide by the x. Okay. And so that's going to cancel. The x's go away. Okay. And again, we can flip it so that the variable we're looking for is on the left all by itself. And we would have y minus b, and that whole thing is divided by x, not just the y or the b, but all of it together. So these are going to be a few of the types of equations you'll see at the beginning of the year. Okay, and then as they get more complicated, we'll do those together as well in practice. The next part talks about direct and inverse relationships. Okay. If two things are directly related, do they behave in the same way or opposite ways? Yeah, 50-50 chance. If things are directly related, that means they're going to behave in the same way. So just like when we had that direct variation on your graph, it looks like this one. If one variable went up, the other one went up as well. So they're going to behave in the same way. And on that first set of notes, we did some new signs. And I don't know if you remember seeing this little alpha sign. What that's going to do is allow us to compare variables without having to write the whole equation. So for example, I've got this equation, it says FG. That's another way of saying the weight of something. Okay, if you think of like how heavy it is when you step on a scale. And then we've got the mass, and then gravity is the Earth's gravitational pull, like trying to accelerate something towards the center of the Earth. If I'm only interested in the FG and the M, and I'm looking at directly proportional, I would say F with the subscript of a G. You've worked with subscripts before, right? Have you seen those? Okay. It's just another way to kind of identify the variable. Directly proportional to, so we're going to do that little alpha sign. It's like a fishy, or the Greek ichthus, if you're in theology classes. That's the fancy name. And we're comparing that to the M. So what this term allows us to do is it's saying I'm going to compare the FG and the M without having to worry about what this G is. Okay. So maybe it's a constant, or maybe it's something, if you're working in a lab, you're going to keep that one constant and not change that variable, and I'm only interested in how these two behave with each other. If you see something proportional to something else and there's no fraction involved, that means if one goes up, the other goes up. If one goes down, the other goes down. They behave in the same way. Okay. So they're going to behave in the same way. So if one increases, the other increases. The more mass something has, the more weight it has. It's heavier. Okay. For inversely proportional, okay, now these are going to behave in opposite ways. So in this case, I'm looking at the V and the T. Okay. So this would be an example of an equation for speed. Speed's distance over time. So if I were to write it as inversely proportional, I would start with the V. You still do the fishy the same way, okay, the proportion sign. And then since it's inversely proportional, I'm going to put a 1 as a placeholder in the top. That means perhaps in this case we're keeping the distance constant, so we're not going to change that at all. So we use a 1 as a placeholder, and we're interested in comparing the speed and the time. So if you were to do a lab and things travel the same amount of distance, the one that has less time to travel that distance has a greater speed. It's going faster. So these are going to behave in opposite ways. The smaller the time, the bigger the speed. Or the opposite. If something took a really, really long time to travel a certain distance, it's going to be going very slowly. So it would have a slow speed. So directly proportional, no fractions. Indirectly or inversely proportional has a fraction, and it's going to be 1 over something when we compare them. Our next section is on dimensional analysis. Okay. So there might be times in physics when we get a few equations, and you're like, oh, I can't remember the equation, but I know what the units are supposed to be. Learning the units are going to be really helpful for you because, again, if you can't remember an equation, you could figure out how to manipulate those things based on what the unit should turn out to be. So you can treat units just like you would algebraic quantities. And when I say units, that's what we're calling dimensions. Okay. So I'm just going to put units in the parentheses. So for example, the dimensions of a length would be meters, okay, which is the unit for length. As long as quantities have the same dimensions or the same units, you can add or subtract them. You cannot do that if they're different. So for example, if you guys are doing your metric Olympics and you measured out 1 meter and then you have 20 centimeters, you don't want to add those together. You want to put them both in meters and then add. So you cannot add or subtract two different units. Okay. And then once we get to our equations, both sides of the equations need to have the same units to work out. So I have an example for you. I believe in your notes it prints out the car travels at a speed of 93 kilometers per hour, and how much time will it take for the car to travel in kilometers. So out of all those units, we know that time should end up in hours for what's given. And we know that speed is a way of saying some sort of length over time. And we know that distance is in length. And we're looking for the answer with a unit of time. So let's say you don't know the equation yet, okay? And we're just trying to work it out with the units. If we were to multiply the length times time and the length together, you would get length squared. So that would be like, say, 93 kilometers per hour times 744 kilometers. Okay. We're getting a length squared per time. If I multiply kilometers per hour here times kilometers, that gives me kilometers squared per hour. Is that a unit of time? No, it's not. So I did that correctly. You don't need to multiply those two numbers together. So if we try another way and say length divided by length per time, then those lengths would cancel. Okay. So if I had kilometers and then divide by kilometers per hour, and I actually wrote that one out. Okay. So if I had my kilometers number and I divide by kilometers per hour, you know that when you have a double fraction here, you can multiply by the reciprocal. And we're going to see that we've got kilometers times hour and then dividing by kilometers. What happens to the kilometers in that fraction? If I have one on top and one on bottom? Good. They're going to cancel out. Okay. And that leaves me with just hours, which makes sense. Hours is a unit that's acceptable for time. Okay. So if you're good with equations, that's fine. You can just rearrange algebraically and figure out what the t should be, like we did on that first slide. Or if you're stuck and you know what the units should turn out to be, but you can't remember a formula, you can manipulate it in different ways and make the units work out. And then that would give you another way to work a formula. It's just an extra tool for you to have. Okay. Does anybody still need that slide? Are you writing? Okay. And we need to have the dimension and the units must agree. So for example, with area, okay, what should area be measured in? Like, how do you find area of something, just in general? You find the area of a square? Are you that rusty from summer? So we know that we're going to multiply two sides together. Let's say that I multiply 2,035 centimeters by 12.5 meters. I can get a number and come up with something, but when I look and multiply the two units together, I've got centimeters times meters as a unit. That's not the correct dimension for area. For area, you need to have something squared for that dimension. So we want our units to agree with each other so that that dimension of having something squared is going to turn out to be correct. In the metric system, what should you measure length in? Is it inches, yards, centimeters, meters?
Oh.
Meters. So when we have a length, we want it to be in meters. So if I were to take this first number, the 2035, do you know how many meters that would be? Do you know how many centimeters in a meter? Do you remember that from last week working with those strips? Yeah, good, 100. Okay, Okay, so how many zeros are in 100? 2. So we're going to move the decimal 2 places. So if I change, instead of having 2035 centimeters, I'm now going to move my decimal 2 to the left and turn that into meters. And now I can multiply those two together. And when we multiply and have our dimensions of meters times meters, those units agree. And we're going to get the correct dimension for area, which is meters squared. So remember, adding and subtracting, things have to be the same units. And then if you were to multiply or divide numbers, you want to look and make sure that those units agree with each other to give you the correct dimension for something. And then we're going to practice with meters per second and kilometers per hour. So units can be important. So if I ask you to compare two numbers, 60 meters per second or 60 kilometers per hour, if you didn't have any units at all, those would be equal, 60 and 60. Okay? But the units make a difference. If I've got something in meters per second and then I have something in kilometers per hour, I can no longer compare accurately those two numbers of 60. They're not going to be the same anymore, even though they both say 60. So what we're going to do is convert. You'll end up needing to know how to convert both directions. And so I'm going to show you both of those today in our examples. If you have your calculator, you're welcome to use that. I'm also going to write it up on the screen, but if you want to practice, you can do that as well and follow along with me. So I'm going to start out with the 60 meters per second. And on this first one, I just mentioned you're going to need to know how to convert meters per second to kilometers per hour and vice versa. So since I started with that direction, we'll have our meters per second first. And you can either do a fence or parentheses, whichever way you learned in algebra. And I want meters to cancel because I'm trying to get to kilometers. So should meters go on the top or the bottom to cancel? Bottom, good. And then we've got kilometers. Which one's bigger, a kilometer or a meter? Yeah, kilometer's bigger. Do you remember kilos power of 10? Or do you know how many meters are in a kilometer? So remember, for this first couple of weeks, you have that chart to look at. Kilo is 10 to the 3. Okay. Or you could write 1,000. So that's going to allow my meters to cancel out. Okay. I also want to change seconds to hours. Okay. This time, since my seconds were in the denominator, I'm going to place those up in the numerator so it'll cancel. Do you know how many seconds are in 1 hour? That's minutes. So 60 seconds in a minute. How many minutes in an hour? 60. Yeah. So both of the, you're going to multiply those two together. So 60 seconds in a minute times 60 minutes in an hour. 60 times 60, that gives you 3,600. I could have changed to minutes first and then hours, but you'll see this conversion a lot, so I went ahead and jumped just to give you that extra conversion factor to have in your knowledge. So what this allows me to do is multiply every number across in the numerator, and all my units canceled out except for kilometers. And then I'm going to divide by, and we're going to multiply everything across in the denominator. And we were left with only hours in the bottom. So 3,600 times 60 times 1 gives me 216,000. And then we ended up with 1,000 on the bottom when we multiplied 10 to the third times 1. So at this point, you can simply divide your numbers. Move that up a little bit. So all those 3 zeros are going to cancel out, and we'll be left with 216. kilometers per hour. So now we can actually compare it to that original value of 60 kilometers per hour. And it's easier to see that 216 is now much, much bigger than 60. So if something's traveling in meters per second, it's having to go much more quickly than something in kilometers per hour if you look at those same numbers. Meters per second to kilometers per hour, you're always going to multiply by 3,600 and you'll divide by 1,000. Okay. So that's kind of a shortcut. Whenever you're going from meters per second to kilometers per hour, you'll multiply by 3,600, then divide by 1,000. By the way, if I were to look at that and I were to multiply by 3,600 and divide by 1,000, what's that turn out to be? 3,600 over 1,000. Yeah. Okay, 36 over 10, and then one more spot to get rid of the 10. Yeah, 3.6. Okay. So I could reduce down my zeros to 36 over 10 or 3.6. So you could, if you remember the shortcut, you could just say, oh, I need to multiply by 3.6. Okay. That would give you the same answer. Our last thing has an example problem. Okay. And then we're going to find our answer in kilometers per hour and meters per second for both of those. Okay. So when we do word problems in here, it's really helpful if you write down everything that's given to you. So I've got 13 kilometers. And hopefully you know that that's a type of length. I'm going to call that distance, okay, since we've kind of worked with that a little bit today. And hours tells me what kind of quantity?
Time.
Good, time, thank you. And we're looking for speed. Okay. So in this case, speed is a way of looking at a length per time. So we would be dividing distance over time to find our speed. I'm going to plug those numbers in and say 13 kilometers over 2 hours. What's 13 over 2?
6.5.
Okay. Is it too early for you guys doing math in the morning? And we were looking for an answer in kilometers per hour, so that told us divide kilometers over hours. Okay. So that part was easy. Do you have questions on the first half? You're also asked to find your answer in meters per second. So what I'm going to do is take that answer that we found that was kilometers per hour, and we're going to set up our conversion like we did earlier. Okay. This time it's going to be a little bit backwards. You'll notice that our fractions are going to be the inverse of what we had before. So I want kilometers to cancel, so I'm going to put that on the bottom. Do you remember how many meters in a kilometer?
10.
That was that, seconds and hours. 10 to the third, or 1,000. And then tell me again how many seconds are in an hour? Good, thank you. Notice this time, in order to get my units to cancel and work out to the ones that I'm aiming for, the fractions were flipped. So this time I'm multiplying by 1,000 and dividing by 3,600. And you can type that into your calculator. And you should get about 1.8 as your answer. So on your Kia quiz that you're gonna have in the next couple of weeks, it'll be due the night before your test. And then also on the test itself, you'll have a couple of these conversions, and you'll have to know to go both ways. Kilometers per hour to meters per second, and meters per second to kilometers per hour. Is there anything you would like to review today?